Good afternoon, everyone. My name is Dr. Nagaraju, Assistant Professor, Department of Computer Science, Artificial Intelligence and Machine Learning, Institute of Aeronautical Engineering, Dundigal. Today, I am here to discuss a topic on Introduction to Artificial Intelligence. So, the two main objects we are going to talk about when we are dealing with artificial intelligence is one is the human and another one is the uh, machine. So I can say that these are the two main important objects that we require whenever we are talking about these artificial intelligence concepts. Means two people are involved in these aspects. One is human and another one is a robot, or we can say that it is an artificial intelligence machine. Okay, here a question may arise, that is why these two people are involved. Definitely, we whenever we try to see these things, definitely we will try to see the similarities between the two different objects. Means for a particular situation, when two objects are involving, that means that two objects are working on a common thing. Similar to that one in the artificial intelligence also, the two main objects like humans and robots, they are going to work on the same thing, that is problem solving. So humans and the machines, they are going to work on the problem solving mechanisms itself. What the humans require to solve the problems and what the robots require to solve the same kind of problems. As we know that either the humans are either the humans or the machines, definitely they need to have knowledge as well as some intelligence. I am repeating the statements. In order to solve a particular problem either by a human or by a robot, definitely they need to have both knowledge as well as intelligence. Here we will talk about the humans. As the humans, we know that we can able to get the knowledge. This knowledge we can get from the surroundings, especially through our observations. For specific problem solving, the humans require some knowledge. This knowledge he is going to grasp from the observations doing from his surroundings. So we can say that the observations are going to provide some set of information to the human, which can be used in order to solve the problem. Okay, so these observations are the knowledge. This observation or some set of information, whatever he is gaining, that we can say that it is a knowledge. Whenever this knowledge is acquired by the human, then he can go for applying that knowledge in order to solve a particular problem. Means knowledge is going to apply to solve a specific problem. Means whenever the user is applying this knowledge, so we say that it is an intelligence. Means human is exhibiting the intelligence in order to solve the problem. Means the primary criteria required to solve these problems is acquiring of knowledge. Similar to that one, when you come to the robots, as we know that robots are also nowadays, our AI machines are nowadays we are using in order to solve the problems itself. So for this one also, they require knowledge as well as they require intelligence. The biggest question is how these robots are going to get the knowledge, how the AI machines are going to apply this knowledge and exhibit that intelligence to solve the problems. As we know that the robots, they cannot do by themselves. So what the humans has to do, the humans has to feed the knowledge to the machine. So we can say that the knowledge, whatever the human is acquiring, that knowledge need to be fed to the artificial intelligence machine in order to solve a specific problem. Okay, so this is in this particular point we need to understand the exact difference between the knowledge and the intelligence. Knowledge is nothing but some set of information or some kind of information we are going to acquire by seeing our surroundings. That knowledge we can use it in order to solve a particular problem. So using of knowledge to solve the problems is nothing but exhibiting our intelligence. Till now, the humans are following the same kind of strategy in doing the problem solving. Here our motto is we need to make the machines think in the same way as the humans are thinking in order to while they are solving the problems. Means our primary duty here is to make the machines to understand, to think just like the humans and solve the problems whatever we are giving to them. So after knowing the difference between knowledge and intelligence, knowledge is nothing but what we are acquiring from the surroundings, are nothing but which is the information which we are going to use in order to solve a problem, and intelligence is nothing but the application of our knowledge. So according to the sources, there are three different kinds of intelligence, we can say. One is called as excellent intelligence, one is good intelligence, and another one is useless intelligence. So let us try to understand what these intelligence are. Okay, so I'm going to talk about these things in the form of representations. Means I want to explain the difference between these intelligences in the form of knowledge representation. Okay, right. The knowledge representation means whenever you are trying to solve a specific problem, your first and foremost thing is you need to represent the knowledge. Means whatever you understood about that problem, that you have to represent in the form of a knowledge, where we are going to use some kind of symbols for representation. At present, we will talk about that this knowledge representation we have done in the form of English. Means using some English language, we have represented some knowledge. So if this knowledge is directly able to understand by anybody, if this knowledge is directly understood by anybody, then we can say that such kind of knowledge, we can say that it is a excellent knowledge. Or otherwise, if this knowledge representation means whatever the knowledge you have represented here, if that is able to directly apply to a specific problem to get a solution, then we can say that that is an excellent one. Means the humans has represented the knowledge in an excellent way. But sometimes what happens is this knowledge representation that we cannot directly use it to a specific problem. So what happens is at that time you need to take that existing knowledge and you have to do some kind of modifications, and then you have to use it for the problem solving. Then at that case we say that it is a good kind of intelligence. Okay, and the third one is either the existing knowledge is useful to you, or the newly or you can, even if you do the modifications, it will not be helpful to you to solve the problems. I'm repeating the statement once again. That is right. If you one is existing one, means whenever you are using the existing knowledge, that will not be suitable for your problem solving. Okay, and another one is even by doing some kind of modifications to the existing one. And even in this case also, it will not be helpful for you to do the problem solving. So what we need to do is we need to create our new representations. We need to develop our own representations to solve it. So in this case, what happens in these two cases, we can say that the knowledge whatever we are having, that is completely a useless one. In another words, if we talk about in another words, then we can say that a knowledge which directly understands, which directly understood by anybody, then we can say that it is an excellent knowledge. Even sometimes what happens, even if somebody is explaining it clearly, then only we can able to understand. Means directly by reading it, we won't get understood. So in that case, we can say that it is good. Even if you are reading directly, you are not unable to get it, and even if somebody is explaining it, still also you are unable to get it, then we can say that it is a useless intelligence. Here we need to always concentrate on the excellent one. Means in terms of knowledge representation, if you speak, right, you should supposed to develop, or you should supposed to represent the knowledge which can directly be useful in applying to any kind of problems. Once we get the idea, or once we get a knowledge about the differences between knowledge and intelligence and different kinds of intelligence, next we need to understand what is the main requirement, or what is the main need that human have, why he has created a machine and why he is making a machine to think. Okay, so for that one, first of all, we need to understand what is the definition of artificial intelligence. Then after, we will try to get some of the reasons which are making the human to create a substitute. So we can say that artificial intelligence is the study of how to make the computers to do the things at the moment people do better. Already I spoke that the two people who are involving in this particular area is the humans and the machines. Humans are working on the problem solving, and machines also working on the problem solving itself. But here what we are doing is we are trying to generate our own substitute. Here already we know that the humans are the very intellectual people, and they are already proven that even some critical kind of problems also they could able to solve. But still what we are doing is we are creating the machines to think and to act just how the humans are doing nowadays. That is our motto. Means the introduction of this artificial intelligence is to make the machines think exactly how the humans are thinking nowadays. So some of the research people, they are already saying that AI is nothing but already implemented. Here the question is why it is already implemented. So there are two different areas where the artificial intelligence is already implemented long back. For example, if you talk about game playing, especially there is a gameplay called as Samuel's chess playing game. Okay, chess playing game, which is a game which is already implemented using artificial intelligence long back. And similar to that one, there is a program called as logic theorist. There's a problem called as logic theorist, which is also an artificial intelligence kind of problem only, where this algorithm or this concept is going to use in order to solve the mathematical problems. So already this chess playing game is there. Already the mathematical theorem proving programs are also there, which are related to artificial intelligence. That's why the people started thinking that artificial intelligence is already implemented one. There is no need of implementing newly. But here our entire thing is different. Means we are not just thinking the artificial intelligence just to do game playing and just to do the problem solving, but we are thinking beyond that. Means we are not thinking that artificial intelligence machine should come to us and we should play a game, a chess game, and it can win or we may win. Our expectations are completely different, just not to play the games or something else. So the computers, as we said, that they are very fast enough to generate different kinds of solutions to a single problem. Means, for example, if being a user, being a human, so generally what we do is we will try to depend on the machines whenever we are having some problems, which makes us to solve it difficultly with a level of difficulty. So generally what happens whenever the human is having some kind of problem, he is going to depend on the machines. Okay, for problem solving. Okay, so we can say that there is a problem to the human, that problem is given to the AI machine by converting this problem into a program. So what happens, the program is having some capability, right? It is having some capability where it is going to generate multiple solutions for us. So we can say S1, S2, S3, like that up to Sn. The problem is one, but the capability of the programs, already existing programs, is they can able to generate multiple answers to you. So from these multiple answers, the user is having a provision in order to select the best one. Or otherwise, we can write a program which can generate multiple solutions and which can pick up the best one from the solutions. Okay, so this is a kind of thing what we have, and the humans at this present moment, what they thought is it is very easy to develop such kind of programs. Means this kind of programs which can generate multiple solutions and select a best one from it. Okay, only small kind of it is a very small kind of task where it is very easy to write the programs and we can generate the solutions to them. But unfortunately, what happened is we can say that these are the assumptions. They are the assumptions. What are those assumptions? One is we are thinking that artificial intelligence programs are the general programs which they can generate multiple answers and it can get a best one, and also only very little effort is needed for that one. These tasks, so what happens here, these tasks are require very little knowledge. Of course, at that particular moment, it means at the time of game playing or at the time of theorem solving, means in 1950s, we can say that the problems whatever we have, means whatever the artificial intelligence problems we have identified, those problems requires a little effort. Means simply it is very easy to write the programs and solve such kind of problems. So this is a kind of assumption where we are. But unfortunately, what happened when the days passed away, the complexity of the problems getting increased. Okay, the problem complexity is becoming higher day by day. So what happens when the problem complexity increases, it will be very difficult to write the programs, or it is very difficult to generate the programs to do the task. Okay, for example, think that you are talking we will talk about a chess playing game itself. A chess playing game. Already we know that if you want to make a AI machine to play the chess, first of all, what we have to do, we need to make the AI machine to think about the legal moves first of all. Means whatever the different kinds of legal moves that can be done or that can be implemented while playing a game. Along with the legal moves, we need to make the AI machine to understand how to win. Means if you want to make a AI machine to play a chess, first of all, you have to write some instructions which can tell you all about the legal moves, and also at the same time you need to tell to the AI machine with some instructions how to win the game. But if you see in this particular scenario, the chess playing game in the chessboard, if you take the chessboard, right, you can represent that board as a 8x8 matrix or a 8x8 array. Whenever it is the case, so if you talk about the legal moves, right, if you talk about the legal moves are the number of positions where the chess player can move, then it will be of 10 to the power of 120. So in order to develop the AI kind of problem for playing the chess, first of all, we should able to generate these number of instructions. So being the human, it is very difficult to write these number of instructions. And at the same time, even if it is possible to write, it will be very difficulty to implement or to complete the program without any errors. So what happened in this particular case, it became very difficult for the human to write these number of instructions. So what happened, the humans started thinking about the substitutes. Here what the substitute has to do, the substitute has to think just like the humans. Means it's a kind of implementing some kind of human reasoning, we can say, and it has to generate or it has to give the solutions which can take only less time. The difference in the problem solving, if you speak the difference in the problem solving among the humans and the machines is the same one. What is that? Time complexity. Time is a major factor. Of course, the humans are also capable to solve the problems, but when it comes to time, there are few problems which we are going to discuss in the upcoming sessions. There are few problems which can take even sometimes lifetime of a human also. But we cannot stop them. Anyhow, at a particular point of view, definitely we need to identify and we need to solve those problems. So what we are doing, we are trying to depend on the machines. Means with this particular example only, it came to know that it is not that much easy to write the artificial intelligence programs. So up to this means up to this particular point, whatever the assumptions we have done, means it's very easy to write the AI programs. Such kind of assumptions became meaningless. So lot of effort is required in order to understand the artificial intelligence problems as well as to represent the knowledge, and then after applying it to show the intelligence. Means especially in the problem solving mechanism, first it starts with the understanding of the problem. First it will start with the understanding of the problem. So means the human has to understand this problem, and this entire understanding he need to convert into knowledge representation. He need to convert into knowledge, and that knowledge need to be represented in such a way that even the humans can also, machines also can understand. Means mostly the knowledge represented by the human will be the English representations. These English representations we need to convert into the machine understandable requirements, representations, we can say. So that includes some symbol kind of things. Once we are ready with the symbol kind of knowledge representation, then we need to feed that to an AI machine to solve it. Okay, so this kind of complexity arised while solving the artificial intelligence problems. Okay, let us talk about the focused area. Nowadays, artificial intelligence is, even the research community is focusing on a specific concept called as common sense reasoning. It is very, very important in order to inject or in order to feed common sense reasoning kind of things also into the machines. Okay, what generally the humans will exhibit every time in solving the problems. Okay, for example, think that think that we have written a artificial intelligence program which should make a robot to cross the road. Okay, so we have designed a artificial intelligence program which should able to make a robot to cross the road. So in this case, what happens is we are going to write some kind of instructions. Going to write some kind of instructions keeping in mind certain objects. Means especially if it is a road, generally we are going to think about a road. We are going to think about the pedestrians. We are going to think about pedestrians. We are going to think about vehicles. We are going to think about the signals. Okay, like this, what we have to do is we need to identify the different kinds of objects that involve in that particular scenario. What is our scenario here? What is our case? We need to make the robot to cross the road. So our primary duty is, whenever we are trying to implement this common sense reasoning, our first duty is we need to identify the different physical objects that involve in that scenario. Okay, in that particular scene. Then after, we need to identify or we need to represent the relationship between the objects also. For example, think that unfortunately when you are writing the programs, you missed to talk about animals. Right? You missed this particular point. Means you didn't identify this object while writing the programs. But unfortunately, when the robot is trying to cross the road, what happens if the animal approaches to it? Okay, so it is not going to perform any kind of action. Why? Because the knowledge representation is completely based on these objects only. You also represented the knowledge and its relationship for these objects itself, but you forgot to keep this one. But unfortunately, what happened in the real time scenario, it means in the real time scene, right? Instead of a vehicle, as you have given instruction that whenever a vehicle approaches to you, to the robot has to stop and it has to come back. Okay, but in the place of vehicle now, an animal came. So what happens? The AI machine is not going to take any action. Why? Because it is not represented in the knowledge fed to the AI. So in this case, what happens whenever we are trying to implement this common sense reasoning, it is very, very important to identify all the objects which are involved or which are required to write the instructions. And at the same time, you need to mention or you need to show the exact relationship among the objects. Let us try to see some of two examples, right, which can clearly says how and where the common sense is required, especially in problem solving. For example, if you see the first picture itself is clearly telling that the programmer has developed a program and fed something to the AI machine which can able to cut a wood. But unfortunately, what happened? The position of the robot is telling that it is sitting on a specific branch, So what happens when that cutting process is completed? Along with that branch, that wood, the AI machine is also going to fall down. So in this particular case, we can say that we have not implemented the common sense reasoning. We have not thinking about the common sense. Being the human, we could easily know that if we cut that wooden branch, along with wooden branch, we are also going to fall. Of course, being a human, we can do. We can understand what is going to happen next. But how the machines are going to think? Already we are saying that our primary motto of developing these AI machines is to make them to think just as the humans are thinking. But we know that humans think with the common sense. But are the machines are going to think with the common sense? Of course, we can say that at present it is not. But the research community is really working a lot in order to implement this kind of common sense even in the machines also. For example, if you see the second scenario, if you give this picture to the AI robot, or if you make a AI machine to enter into this room, the machine has to understand that this picture belongs to a kitchen room. And it has to understand what are the different objects that involve in that kitchen room, and also what is the relationship that exists between. Means if you want to make a AI machine to cook something, means some fun kind of food, then it should know that what are the different food items and how that food items need to be used and how to glow a stove, right, and how to perform the cooking. All these things you need to know. How the machine has to know, but how it can able to understand it until and unless you instruct or you write some instructions related to all the objects present in the kitchen and also the relationship among the objects. And if you could able to feed the common sense, then only a machine can cook something and it can give to you. Of course, these are the two simple examples where I want to tell why the artificial intelligence machines require common sense. Let us talk about the improvements in the artificial intelligence. So I have taken this picture from the internet, and this picture is clearly telling a lot about the improvements. Today we can say that we are at this particular state. We are successful. Being the humans, we are successful only to exhibit a narrow intelligence, we can say. So what do you mean by this narrow intelligence? I want to take some simple examples. For example, if you see this Siri, Cortana, if you see Alexa, all these programs are available. So what these programs are implemented by using artificial intelligence itself. The primary motto of these applications is to give service to the humans. Okay, for example, if you want to switch on and switch off your lights in your home, then automatically you can do it by just giving the instructions to these programs. So now the question is, why I am saying these things as the narrow intelligence. Of course, they are doing the things very smart, but still I am telling that they are the narrow intelligence. Why they are narrow intelligence means they are going to exhibit their behavior, right, as it has programmed. Means whatever the programs that are feeded in that application, they are going to work just like that. For example, if you ask some Cortana or Alexa, who is your father, then it could able to give the answer of the person who really developed them. But if I change the question and ask who is my father, then it is not going to give the answer. Why? Because these applications or these machines are not fitted with that question. Means they are exhibiting their behavior to a specific need, to a specific purpose. Means those applications are not thinking by themselves. They are going to exhibit their behavior based upon the programs fed by the humans itself. Means some kind of limitation is there in exhibiting the intelligence. That's why we say that it is narrow intelligence. So what tomorrow we are going to see? Tomorrow definitely we are going to see some common sense kind of artificial intelligence programs or machines. Means they are going to think of themselves. But still we cannot say that we have succeeded or we have achieved a higher level of progress until and unless we move to this general artificial intelligence. So here we need to understand the difference between these. In the future general artificial intelligence, what happens is our primary motto is we need to make a robot. We need to make a robot to think of itself, act itself, and exhibit the behavior by itself. Means there will be no involvement of the humans. So in these two cases, what happens? Some kind of human involvement will be there. Right? But in this case, we are expecting to have a artificial intelligence at a particular level that it has to exhibit its behavior without having any support from the humans. That is actually our future. So definitely hope we are going to achieve this general intelligence, or we can say that future artificial intelligence in the coming 10 years or 20 years. So what is the progress of artificial intelligence? Today, there are a lot of techniques already available which are related to this artificial intelligence. Those techniques they are ready to handle large amounts of data. We can say even large amounts of knowledge also. Means as we are dealing with artificial intelligence, instead of data, most of the cases we use a specific term called as knowledge. Means the present artificial intelligence machines are capable of handling large amount of knowledge. Because of this capability, artificial intelligence has shown a lot of progress in different application areas. For example, if you see, artificial intelligence is already proven at the area of computer vision. It has already proved in the image and speech recognitions. It already proven in the object detection. They are already proven in the object identification. It already proven in the object segmentation. Not only in this particular area, so in the different medical fields also, artificial intelligence is already proven that they are exhibiting a very good behavior how the humans are not doing nowadays. Medical in the humans perspective, and also we can talk about the agriculture perspective also. Okay, so in this case we can say that the artificial intelligence with the help of the subsets of AI. Okay, as we know that artificial intelligence is the main area. Okay, so we can think this is a main area. In this main area, again we are having a sub domain which is called as machine learning, and along in this we are having one more which is called as deep learning. Means with the help of these subsets, the artificial intelligence nowadays it has proven to solve even more complex tasks in the area of computer vision, image and speech recognition, object detection, medical case, and even we can say that at the area of natural language understanding also. This is the primary area where nowadays lot of research is going on. Natural language processing is different, and natural language understanding is different. Natural language processing is just kind of taking some basic inputs from one language and do some kind of translations. But here, natural language understanding is not the point of just doing some kind of translations, but to understand what the sentence is telling all about. Okay. Coming to the perception of the world. So here, being the human, right? Our primary duty is we need to survive. Of course, there will be other needs to the humans, but the primary thing what the human require is survival. Okay, so how the human is going to survive? It's completely depends upon the knowledge he is acquiring. Completely depends upon the knowledge he is acquiring, and also how he is using that knowledge in order to solve his regular kind of problems. Regular kinds, or we can say that some kind of problems. Means at the time of problem solving, if the human wants to solve them, definitely he need to have some knowledge. The question is how the human is going to get such kind of knowledge. Until and unless he is going to do some kind of observations around the surroundings, he is not going to know anything. If you don't have the knowledge, he cannot apply it. When he won't apply, he is not going to solve any kind of problems. But the biggest weapon what the humans is having is a communication. The humans are able to communicate. With that communication, the humans can able to get lot of knowledge. If you talk about the animals also going to get some kind of knowledge by the surroundings itself. But the lack is they cannot communicate. Of course, they can communicate with their own language. Okay, with their own language with the animals itself. Right? Very rarely we found that it can communicate with some other objects and it can grasp the knowledge. Means purely the perception around the surroundings, the animals are going to get some kind of knowledge by their visualization itself. They are not going to get that much of knowledge through the communication. But humans are having that good weapon with them. So actually, this perception, getting of this perception is very difficult. Why? Because it is going to involve some kind of analog signals. So as we know that those analog signals are some noisy. Means we cannot use such signals directly, and you cannot apply it to your problem solving. But what you have to do is after capturing these analog signals, you have to do some internal kind of processing. So we can say that it is an input processing or data processing, we can say. Until and unless you perform the data processing, you cannot apply them to your problem solving. So let us talk about this ability of communication. Already I spoke that the humans are having a very good ability, that is they can communicate. When they communicate with each other, they are going to get some new ideas. Getting of new ideas is nothing but improving their knowledge. Once they have enough quantity of knowledge with them, they can able to apply those knowledge for different kinds of problems. So especially here what happens is the problem is going to come with the spoken language itself. In the perspective, right? Generally what happens is if I could able to communicate with the other person with the language what we know, then it will be very difficult. So here what happens, here there should be a common thing. There should be a common language which can make myself to communicate with the other people. But here what is happening, at one end human is there. The human is not going to communicate with the other human. But here what is happening, the human is going to communicate with a robot. Why? Because the robot is going to solve the problems to the human, means which are related to the human being. So what happens here, the spoken English, or we can say that some spoken language, we can say. Some spoken language kind of things, it is very difficult to make the machines to understand. Until and unless, even humans, for humans also it is very difficult. Why? Because the humans also should need to have lot of knowledge in order to understand what the sentences in that particular language is all telling about. The human should be in a stage to understand what the sentences are telling, and also he need to come to a conclusion after reading the sentences. Until and unless he has a very good grip on the language, even he cannot understand what he is reading. The same thing, the same problem it will be there with the machines also. Translation means simply we can translate, means we can write some English kind of sentence and we can make the machine to translate it in a different language. But here we are not talking about natural language translation. We are talking about the natural language understanding. Okay, so it makes very difficult for the humans also, right, and even machines also, in order to do such kind of communication. So what has there is a substitute. We are getting some kind of substitute. Why? Because here the problem we are getting is due to the knowledge. See, for solving any kind of problem, the primary thing what we require is knowledge. Generally, what happens? This knowledge, it will be created. It will be created by the humans, or it will be used. Means existing knowledge can be used, or it can be modified. Means he can take the existing knowledge and he can do some kind of modifications so that it is applicable to the specific problem. Okay, so these three things are very, very important. Until and unless you have the knowledge, you cannot go for any application. Means you cannot able to exhibit any intelligence. So for time being, what happened is there are some expert systems which are already available in the market. So these expert systems are having some thousands of programs. These thousands of programs are having different kinds of knowledge representations. If you require, directly you can use this knowledge and you can apply to your specific problem solving. If you feel that a knowledge, for example, if this is a knowledge, this knowledge is directly useful and it is applicable to your specific problem solving, then directly you can use it. Sometimes if you feel that only part of this knowledge representation, means in the entire knowledge representation only part is useful for you, then you can extract only the part of this knowledge and you can use it. It's not necessary that all the knowledge representation you have to take and you have to go for applying. If you feel that the entire knowledge, whatever what is represented is useful for you, then you can directly use it and you can apply it. Means you can apply it to your problem solving. But we cannot guarantee that every time for our problems the knowledge is already available in the expert systems. But some kind of matching will be there. So in that case, what you have to do is only you can pick up only the part of the knowledge which you are thinking that it is applicable to your problem, then extract them and use it. If you feel that the existing knowledge is not suitable for your problem solving, and the part of the knowledge also not suitable for your problem solving, then we have to create our own problem knowledge. That creation of knowledge completely depends upon the way how we are understanding the problem. Okay, let us talk a little bit about this natural language understanding. Just now I spoke that it is not that much easy as we do with the natural language translation. It is very easy to take one English sentence and translate into Telugu, or Telugu sentence into English. But when it comes to natural language understanding, it is very difficult. Why? Because the understanding of sentences, especially to a particular topic, it is very difficult. Of course, being a human, right, we can exhibit our intelligence. We can show our knowledge here. But this should be done with the machines. So in the perspective of machines, we can say that understanding of such kind of sentences to a specific topic is very difficult. Until and unless you have a very good knowledge on a particular language. So you should know a lot about the knowledge. Okay, so and also needs a good deal about the topic to recognize and unstated assumptions. To recognize the unstated assumptions means as we are the humans, we can apply common sense every time. After reading a specific topic in the article or some paragraph in the article, simply we can come to a conclusion and we can say that this paragraph is telling all about this point. But what happens if you want to see same kind of behavior in machines? Is it going to exhibit the same results what the humans are exhibiting now? So at that point, at this point, we can say that the machines are not that much capable so far. In future, we may expect that even the robots also can understand the natural language, means whatever we are speaking. Of course, in some particular areas, the robots are already good enough. They are so intelligent and they could able to communicate with the machines. But still, we can say that it is limited only. Okay, still lot of research need to be happen in order to make the machines communicate just as the humans communicate. So if you want to study about this artificial intelligence, first of all, we need to know what are the different kinds of problems that artificial intelligence is dealing with. Means what kind of problems we say that it requires artificial intelligence implementation, and we have to think about the solutions also. So for this one, definitely you need to get some answers for the 4 questions. Right? There are 4 questions to which if you could able to get the answers, then we can easily understand what these artificial intelligence programs are differ from the other kind of programs. So what are the underlying assumptions about intelligence? What we are thinking about the intelligence? Okay, so what particular level also important, means at what level you are trying to implement this intelligence. Do you have any kind of assumptions? At the early time of the session, I told that the assumptions, whatever we have done earlier, they went wrong. Similar to that one, if you are having any kind of wrong assumptions, then you need to remove from your mind. Why? Because artificial intelligence programs are not that much simple. It needs lot of human involvement of human experts. Okay, so the answers you need to get for this question. What is that? What are our underlying assumptions about intelligence? Then what kind of techniques that are already available? There are a lot of artificial intelligence techniques that are already proven to solve some kind of problems. So you need to know what those problems are. Okay, for different kinds of problems, there will be different kinds of artificial intelligence techniques. For example, if you are talking about search techniques, means if your problem is related with such kind of thing, so to implement that, there is a specific technique called as heuristic search. Heuristic search technique, or we can say that heuristic search approach. Okay, we are going to talk about these approaches very clearly in the coming sessions. But at present, we need to get the answers for this question. What is that? What are the different artificial intelligence techniques that are already available to solve the AI problems? So until and unless you don't know what are the techniques that are already available, you cannot able to apply it. And next one is, at what level of detail, if at all, are we trying to model human intelligence? This is also important. Why? Because every time we are telling that we are making machines to act just how the humans are acting nowadays. So even we cannot say that 100% means, for example, if the implementation level of human is 100%, you cannot expect the same thing 100% with the machines. Of course, we may expect in future, but at present we are not succeeding to this 100%. So you need to keep some point, right? What that point has to tell, at what level. Okay, so what level of complexity, we can say at what level of complexity you are trying to solve the problems. Means if you say that the problem's complexity is low, medium and high, then you need to understand, are you going to implement the artificial intelligence for to the problems which require low intelligence, or which require medium intelligence, or which require high intelligence? See, if your problem is complex, then we can say that it is low intelligence is required. Less complex means. But when the complexity is increasing, definitely you need to exhibit a higher level of intelligence itself. So first of all, you need to identify to which category, means to which complexity your problem is related with. If you feel that the complexity is very high, then your level of implementing the knowledge and level of exhibiting the intelligence is also should be high. Next is how will we know that we have succeeded in building an intelligent program? Already I told that thing. Our primary duty is we need to make AI program. Okay, right? In other terms, we can say that it can be an AI machine or it can be a AI program. Okay, but at present we will talk about this AI program. Why? Because we are in the initial stage of understanding this artificial intelligence. Okay, think that after understanding everything about your problem, right? You have represented some knowledge. You have represented some knowledge, and you have used that knowledge in order to develop a program. That program has given a solution to you. Think this has happened. So by seeing this result, are you going to say that you have succeeded in developing a very efficient AI program? So what is the criteria? Right? Definitely there will be some performance metrics will be there. Based upon that metrics values, you need to decide whether you have succeeded or not. And also at what level you have your success is. Similar to that one, if you could able to get the solution by writing some artificial intelligence program, can we say that I have succeeded? Maybe, may not be. So there should be a strategy or there should be a technique which should tell whether we have succeeded in this particular point or not. I mean, there should be some method, right, which can test this AI program and tell that this program is exhibiting a very good intelligence as the humans are doing nowadays. As our primary point, every time our concentration is only on a particular word called as knowledge. So first of all, we need to understand this knowledge, what this knowledge looks like. Okay, see, until and unless we have knowledge with our hand, in our hand, okay, we cannot use it to exhibit the intelligence. Okay, so our primary duty, we need to understand what this knowledge is. For this, we need to know what are the different properties that a knowledge will have. As I said, nowadays the expert systems are having a huge amount of programs. In some thousands of programs are already implemented and they are kept in the expert system. Directly you can use it. You can use it for your purpose. Okay, means with this explanation only we can come to know that this knowledge is not a small quantity. The availability of knowledge is not of small quantity. That is very huge. Okay, so our first property will be it is voluminous. The knowledge is of huge quantity. Once it is huge, then it will be very difficult to characterize accurately. See, to a particular scenario, if only 10 objects are involving, it will be very easy to identify the 10 objects and it will be very easy to represent the relationship between the objects. But what happens if the number of objects involved are very high? So it takes some time. Of course, we can able to do it, but it is going to take some time. But here, the size of the knowledge, we cannot say that it is a small size. When the size is very high, so it will be very difficult to characterize. Okay, and also we can say that the knowledge is not stable. Every time the quantity of the knowledge is going to change. For example, think that this is the knowledge base we are having. Okay, this knowledge base is giving some kind of knowledge which can solve different kinds of problems. For example, problem 1, problem 2, like that, problem M. But what happens when a problem N come to me? So again, what I have to do in order to solve this problem? Again, I need to represent the knowledge. So what I will do after completing my process means after representing the knowledge, after applying it, after getting a successful result, what I will do, I will try to keep this knowledge into the knowledge base. Like that, plenty of research people, they are going to keep their knowledge in the knowledge base. So what is happening here? Regularly, the size of the knowledge is increasing. That's why we say that it is constantly changing. Changing means it can be a newly created one can be added into it, or some kind of modifications may happen. Some kind of reconstructions also may happen. That's why we say that one of the property of knowledge is it is constantly changing. And another one is it is differ from data by being organized and the way how it is used. Okay, this is also very, very important. Means the way how you are representing the knowledge base, you cannot use the same thing to and apply it to your problem. Means the way of organizing will be different and the way of applying is also going to be different. Okay, but anyhow, we are dealing with the same kind of knowledge itself. Even for this class also, I may have studied in a different way. How I have organized that knowledge in my mind is different, and how I am exhibiting here will be different. Means the organization of knowledge will be different, and the way how we are using it is also going to be different. Means these are the 4 different properties that we need to think when we are dealing with the knowledge. Knowledge is of huge size. It is constantly changing. It will be very difficult to characterize. Means this point is telling how much we need to concentrate while representing the relationship among the objects. And it is also going to tell that the way how you are organizing is completely different the way how you are using it. Now, how to define a AI technique? Artificial intelligence technique, we can say that it is a method of exploiting the knowledge. So I want to take one simple sentence, that is intelligence requires knowledge. Regularly we are talking the same sentence. Intelligence require knowledge. Until and unless you don't have the knowledge with you, you cannot able to apply it and solve your problems. So the main motto of this artificial intelligence technique is in order to exploit this knowledge itself. In order to exploit this knowledge. So how you are going to use this knowledge? That is also very, very important point. Coming to the knowledge representation. Okay, the knowledge requires generalization. What do you mean by generalization? Of course, we can talk about this generalization in different ways. But here, I will take one specific example and I will try to make you understand how this generalization representation will be. For example, think that there is a English representation. What I can say that Sita is the mother of Gita. Sita is the mother of Gita. So this is the English sentence, English representation we are having. So what we have to do, we need to convert this English representation into a understandable representation. So how it will be? As a fact, I can represent this one. Okay, what is the fact here? Fact is nothing but here. Okay, one particular statement, a clause we can say in artificial intelligence, where we are going to write first the predicate. So what is the predicate here? The relation. What is the relation? Mother is the relation. So in this predicate, you need to mention the parameters. So what are the parameters I am going to write here? One is Sita and another one is Gita. This we can say that it is a fact. In Prolog programming language, we represent the facts in this way. Okay, here mother is a predicate and these two are the arguments. So when you are representing in this fashion using some logic programming like Prolog, so what happens? It is representing this English representation itself. But what is wrong in this representation? See, it is telling that Sita is the mother of, okay, Sita is the mother of Gita. So tell me, is it a generalized one or the specific one? What happened here? It became specific. Why? Because you are talking about the specific objects like Sita and Gita. But your knowledge representation should not be like this. So what happens if you represent in this case, right? So this can be applicable only to specific kind of problems. But your knowledge representation should be in a stage, it can be able to apply to different kinds of problems. So instead of going for representation in the specific one, you try to represent in a generalized way. So in the generalized way, how I can represent it? Simply I can mention X is the mother of Y. X is the mother of Y. Okay, at the initial stage, I am doing this one. So what happens here? Simply I can mention mother as a predicate and X comma Y as a variable C. One dot. So X can be anything and Y can be anything. Means this kind of representation I can use in order to show the relationship among any two different people. But in this case, it is not like that. So every time when you are trying to represent the knowledge, your concentration should be the representations in this case, in this way. You cannot go for the specific one. Okay, right. And one more important thing is generalization. In this case, what happens? It's not necessary to represent the knowledge as different elements. If you feel that any of the elements or any of the representations are having some common properties, you better to keep all those knowledge in a separate group. Okay, so instead situations that share important properties are grouped together, so that the knowledge base can have the same kind of knowledges in the same place. It will be very easy when you are accessing. Okay. And if the knowledge does not have this property, for example, think that you are finding that some knowledge is not having a property which is common among them. So your primary duty is you need to update it. Of course, this particular point depends upon the requirement of the humans. Means if our program is really required these kind of things, definitely you have to go for the updation of the property. If it is not required, then leave it. You can create your own property and you can use them. So the question is how to present this knowledge. How to present this knowledge. So we need to understand. Means first of all, you see how I am able to give this kind of lectures means the way how I understood. Is the knowledge representation will be completely based upon the way how the humans are understanding. So it is telling the same point. It can be understood by people who must provide it. Means I am going to represent the knowledge, the way how I understood, that is one point. And that knowledge representation can be explainable only by me only. Why? Because I have represented the knowledge. Okay, if I have represented the knowledge with an excellent intelligence, then everybody who took that knowledge to use, then they could able to understand it. Why? Because my level of representing the knowledge is excellent. Okay, so it is very, very important to understand how the knowledge is represented by the people itself who represented it. And for many of the programs, what happens is this knowledge is automatically acquired. Means, for example, when you are dealing with some sensor kind of problems, when you deploy those sensors in the real-time scenarios, that sensors are going to extract some data and it is going to provide you. The data will be collected at some point and it will be used for the further analysis. Means for many of the problems, the knowledge will be automatically acquired. Okay, most of the knowledge a program must ultimately be provided by people in terms they understand. Just now I talk about this one. How I could able to represent a specific knowledge means the level of my understanding. How I understood, in the same way I am going to exhibit my knowledge. Means the presentation of knowledge is also going to completely depend upon the way how I understood that one. If I could able to understand a specific problem in a correct way, I will generate the correct representation itself, knowledge representation. That knowledge representation directly I can use it and I can solve the problems. But unfortunately, if I could not able to understand the problem clearly, something I am going to miss. When I miss something, that representation will not be there. So even if you apply such kind of knowledge to your problem solving, it is not going to give better results. Okay. And how the knowledge should be? The knowledge should be in a stage it can be easily modified, so that it can be easily modified. That modification of knowledge representation is also very, very important. Why? Because at a particular level you may think that knowledge representation is correct and it is sufficient to solve the problems. But in some case you may find that this representation is wrong. So you should be in a stage to modify that knowledge. Otherwise that knowledge is going to be waste. Okay. It can easily be modified to correct errors and to reflect changes. And it need to be used in different situations. That is also very, very important. But remember, even though the knowledge what we are representing may not be accurate, but still we are applying that knowledge in order to solve our problems. Why? Because at present we may be in one assumption. We may think that this kind of representation of knowledge is more than enough to solve the problems. But unfortunately, in future, if the complexity of the problem changes, definitely we have to change the knowledge also. Otherwise, you are not going to get the solutions. So, what is the degree of independence we are having? In general, what happens? There are two different kinds of problems here. One is a non-AI problems, and at the other side, we can say that some AI problems. Okay, non-AI problems are and AI problems, and similar to that one, there will be some non-AI techniques and also some AI techniques. Every time what we think that in order to solve this artificial intelligence problems, we are going to implement this artificial intelligence technique. Similar to that one, non-artificial intelligence technique can be applicable or are applied to a non-artificial intelligence kind of problems. But we are having certain level of independence here. What is that? Sometimes there are some examples we can say that a non-AI problem can be solved with the help of this AI technique. In a similar fashion, a non-AI technique can be used in order to solve a artificial intelligence problem. Okay, this can happen. Let us see some of the examples and we will try to understand how this can happen. Okay, level of the model I am talking about. So, what is our goal in trying this? Means what is our primary motto? Are we going to produce programs? Are we going to produce the programs that do the intelligent things that nowadays people are doing? Okay, and also at the same time, are we trying to produce the programs that do the tasks the same way the people are doing? And also, are we attempting to produce programs that simply do the things in whatever it appears easy? Means, are we going to exhibit any kind of going to develop any kind of programs that are going to exhibit artificial intelligence? Means the smartness what the humans are showing nowadays in problem solving. Are we going to do an attempt, right, which can give a optimized solution to us? Okay, so this is the level of the model we need to think of. Let us try in this particular scenario. I am talking about this class 1 kind of problems. Just now I told that there are few problems which does not require any artificial intelligence technique to implement. Similar to that one, there are some non-AI programs or non-AI problems where we have to apply the artificial intelligence. You try to observe this one. There is a specific program called as Elementary Perceiver and Memorizer. This is a program which is implemented using artificial intelligence. But frankly speaking, this is not at all related to a task of artificial intelligence. Why? Because this problem is just like this one. There will be some kind of words. Okay, some word 1, word 2, like that. There are a number of words. And for each and every word, there will be some synonyms kind of things. So, synonym 1, synonym 2, like that up to synonym n. So, what this program is going to do is, whenever the user is asking about this particular word, it is going to give the attached synonyms to this particular word as the answers. So, this kind of task, you cannot say that it requires any artificial intelligence implementation. So, that's why we are saying that this is not an AI problem. This is a non-AI problem. But for this non-AI problem, we have implemented artificial intelligence. Let us talk about the second example. This second example is talking about the artificial task itself. In this, I am going to talk about two examples. One example is the testing of psychological theories of human. In this test, what happens is the researchers are going to understand the communication process. Means how a paranoid person is going to communicate. Means they are trying to identify the behavior of a paranoid person. Of course, this paranoid person behavior identification is almost similar, exactly matches with the artificial intelligence kind of problem. Okay. And if you talk about the second example, this second example is to enable the machines to understand this human reasoning. How it will be, for example, think that I have given a statement. I have given this sentence to the AI machine and asked to tell what it is telling all about. So what is that? Why did the terrorists kill the hostages? Means if I have given a specific paragraph to read to a AI machine, and then after reading, I have started asking some questions. What is the question? Why did the terrorists kill the hostages? So in this case, what happens? Even the artificial intelligence machine has to exhibit the reasoning. How the humans are doing nowadays. Means after reading the paragraph, the AI machine should be able to tell the answer for this question. So this is also one kind of problem which is exactly matches with the artificial intelligence task. And what will be the criteria of success? When can we say that we have succeeded? So the question what we need, what we are raising ourselves is, how will we know that we have succeeded? And also, how will we know that we have constructed a machine that is intelligent? And what is intelligence? We need to understand this particular thing also. And but can we do anything to measure our progress? This is also very, very important. Just few minutes back we have discussed about this. When can we guarantee that we have developed a very efficient artificial intelligence program? Until and unless you have certain criteria to test it, you cannot say that you have succeeded in that particular aspect. So how we need to test it? How to test the efficiency of the program developed by us? So in 1950, there is a person called as Alan Turing. This person has given a very good method to test a artificial intelligence program. So what is this test? The test includes three different people. In this case, we can say that three different players. I can say one is player A, player B, and player C. Means in this test scenario, three people are involved. One is player A, player B, and player C. Here, player A is a computer. Means we can say some AI machine, right? And player B is the human. And player C is also human. Okay, player C, we can call it that he is a interrogator. Okay, he is the interrogator. So how the scenario situation will be, you see, there are three different rooms. Okay, sorry. There are three different rooms, right? Here there will be player C. We call them as interrogator. Okay, this interrogator is also human. Okay, he is the interrogator, right? In the other room there will be player A. Okay, he is not the human, but he is a computer. In the other room, okay, there is one more person. There is one more person. He is called as player C. He is represented with player B. So what is this task is? Some questions are given to this interrogator. This interrogator is going to ask the questions simultaneously to player A and player B, and he will try to get some answers from both of the players. But for player C, right, it knows that two other people are involved. One is player A and player B, but this interrogator does not know that player A is a computer and player B is a human. So here, what is the task of this AI machine here, a computer here? Means the computer has to give the answers in such a way that the answers are given by the human itself. If the player A or the computer could able to bluff or able to prove that the answers are given by the human itself, then we can say that we have succeeded in developing a very intelligent artificial intelligence program, or very intelligent program, or a artificial intelligence program. Okay, so this is a very good method that has proposed by Alan Turing in 1950. Okay, this is the pictorial representation I have collected from a website, and I mentioned the reference of this picture also from where I have taken. And this is a Turing test representation. As I mentioned, player A, player B, and player C. The interrogator will start asking the questions to player A and player B, and at the same time he has to get the responses from both the players. If the player C or the interrogator can able to think that the answers given by the player A is human, then we can say that the computer has exhibited a very good intelligence.
Like, share and subscribe. Hit the bell icon for more updates.